This is going to be a combined gas law problem, and I don't have enough room on my screen to write out the problem itself. So what I did was I went ahead and just listed the variables with the amounts and units. And you can see that we have pressure, volume, and temperature. We start with one set of pressure, volume, and temperature, and then it changes. We're assuming that we've got a closed container and that we have a second pressure and a second temperature. What we'd like to know is how that's going to affect the volume. So to begin with, I'm going to write the combined gas law equation, and I'm going to write it so that it's not a fraction. So P2V2T1. I find this is an easy way to remember the combined gas law. So we have P, V, and T on each side of the equation, and the ones are on the left, the twos are on the right, and then temperature switches. So temperature is always 2 on the left and 1 on the right. All right, so then the variable that we're solving for is V2. So I'm going to circle V2. That's the one I want to end up with. And what that reminds me is that I need to divide by everything else on this side of the equation. So I've got P2 and T1. And if I divide it there, I need to divide it here as well. So now P2 cancels and T1 cancels. So the equation that I'm working with now is V2 is equal to P1 V1 T2. It's really important to keep those subscripts straight. Then it's divided by P2 T1. All right, so now all we have to do is plug the numbers in. According to my list, pressure is 1.0 atmospheres. I'm going to multiply that times 2.0 liters and multiply that by T2. So I have to remember to look on this side. Got a problem though. Temperature has to be in kelvins. And so before I plug it in, I'm going to add 273. And so my temperature is going to be 284 kelvins. And then all of this is going to be divided by P2, which is 1.5 atmospheres, times T1. And same thing with T1. I have to add 26 and 273. So I have 299 kelvins. Okay, I'm going to switch colors one more time here. Let's this one. And I'm going to use this to cancel my units. So I've got atmospheres on the top and on the bottom, and kelvins on the top, kelvins on the bottom. So the only unit I'm left with is liters. And since I'm looking for volume, that's good. So the last step then is to plug this into the calculator. And so basically what I'm going to do here is put parentheses around the top numbers and parentheses around the numbers on the bottom of the fraction. If you have a calculator with parentheses, then you can do this all in one shot. 1.0 times 2 times 284, close the parentheses, and then divide that by parenthesis 1.5 times 299, close the parentheses. If your calculator doesn't have parentheses, then you need to multiply the top, write down the answer, multiply the bottom, write down the answer, and then divide the two. And one last tip then is to not do any rounding until you have your final answer. So write down all the numbers you have while you're doing the calculation. And for this particular problem, because I have 2 significant figures in all of my givens, every single one of them. I'm going to keep 2 significant figures in my answer. And the answer is on my calculator 1.266. So I am going to round that to 2 sig figs, and it would be 1.3 liters, and that's my final answer.